Okay, so today let's have a look at the matrices. We look at the order of the matrices, type of the matrices, adding the matrices, subtracting the matrices, and matrices multiplication with another matrices. Now, when you look at the matrices consist of rows and columns. Yeah, usually matrices are written down in a square bracket. So when we write the matrices like in a square bracket. Yep. Let's say it's 1, 2, 3, 4, 5, 6, something like that. Yeah. So these are the matrices. Yeah. Now, then how do we, then there's a thing called order of matrices as well. Order of matrices is row. How many rows are there? This is first row, second row, and how many columns are there? Order of the matrices are is written as like this. This is the order of the matrix. Is row times columns. Yeah. So order of this matrix is how many rows? Two rows and three columns. Yeah. So usually we write row first and then column first. Yeah. Column second. So if there is a matrix like that, we write M cross N, where M is a number of rows and N is a number of columns. Yeah. So it can be any matrix. Yeah. Happy with that? Then we have a thing called um, this is the order of the matrix, by the way. We got the elements of the matrix. Now, what are the elements of the matrix? Then we got the elements of the matrix. For example, I write this matrix 3, 4, 7, 8, 9. Yeah, like something like that. Okay, let's say I got these matrix and I say like, oh, can you tell me where can you pick up the zero? And you think which zero you're talking about? If I say can you pick up the three, which three I'm talking about? There are three threes. So to pinpoint the exact location, we actually identify them with rows and columns. These things inside, like a 3, 4, 7, 8, these are known as the elements of the matrix. Yeah. So elements of the matrix. So this matrix is how many rows? Three rows and four columns. The order is 3 cross 4. Yeah. Now, then we do is we call the elements. For example, the first element is known as A11. Yeah. If this matrix is A matrix A11. A11 is 3. A12, first row, second column. A13, A14. Yeah. That's how we write down the element. So if I say, can you pick me the element A12? So you know A12 is 4. So that will be a second row. A21, A22, A23, A24. That will be A31. Yep. So if I say, can you pick me element A33? So element A33 is this one. Yeah, isn't it? Yeah, so that's easy. That's how we define the elements of the matrices. Now we got the type of matrices. The first most important one, or the most easiest one, is a square matrix. Square matrix is a matrix where the number of the M is equal to number of the N. What is M and N? Number of rows is equal to number of columns. So number of rows is equal to number of columns. Yeah. For example, let me put this one. what's the order? 1 cross 1. Yeah, this one, 2, 3, 4, is 2 rows, 2 column, square matrix. Yeah, this one is 3 cross 3. Yeah, so they all square matrices because number of rows are equal to number of columns. Then we got another one called row matrix. Row matrices are those where the number of row is just one. For example, yep, just one row and two. So these are row matrix. Then we got another thing known as column matrix. Column is a matrix which has only one column. For example, so 3 rows and 1 column. Yeah, for example, yeah, so that's column matrix. Yeah. So we got row matrix, we got column matrix. Then we got a zero matrix. Zero matrices are the matrices where all the elements are zero. Zero. Yeah. Yeah. Then we have a unity matrix. Yeah. Unity matrix is represented by an I, and it acts as a number 1, like 20 times 1 is 20, 13.5 times 1 is 13.5. When you multiply the matrix by I matrix, the answer is always the same. Yeah. Okay. Unity matrix is a matrix where the diagonal is 1. The leading diagonal is 1. This is known as the leading diagonal. Yeah, is 1. But it has to be a square matrix. Yeah. It cannot be a rectangle or the matrix. So see, this is a leading diagonal is 1. Leading diagonal is 1. This is called the unity matrix. So we got zero matrix, we got unity matrix. Then we got one more. It's known as a diagonal matrix. Yeah. In which the leading diagonal is only a non-zero entity. 0.1, 0, 0, 0, 9.2, 0, 0, 0, 3 over 5. Yeah, because you can write fractions as well. So you can see here, this diagonal is a non-zero. Every other element is a 0. These are known as diagonal matrix. Yep. Happy with that? Any questions so far? To add the matrices, the order of both matrices should be same. Yeah. So both matrices that need to be added should have same order. If the order is not same, can't do it. For example, I got 2, 1, 5, 3, 2, 0. What is the order of this matrix? 2 cross 3. Yeah. And I'm going to name this matrix as A. Yeah. And then I got the matrix B. Matrix B is, let's call it 5 minus 10, 3, 4, 9, 2. Yeah, because they both have the same order, 2 cross 3 and 2 cross 3. It means I can add the matrices. First thing we do, we check the order. So this is 2 cross 3 and this is 2 cross 3, which means yes, we can go ahead by adding the matrix. Now when we add the matrix, we write the matrix as A, find A plus B. So I want to find the A plus B. The way we do is this, we write 2, 1, 5, 3, 2, 0. Oops, sorry, a little bit far away, so it looks like it's a separate number, plus B. B is 5, 4, minus 10, 9, 3, 2. Okay, done. To add that one, what I will do is I will add the each element, corresponding element to the corresponding. So this is the A11 and this is also B11. First element of the first with the first element of the second. They will add up. Yeah. These one will add up to that one, and the green one with the green one, and the yellow one with the yellow one, and the red one with the red one, that one. Yep. So you run out of color. So yeah. Okay. So now A plus B will become 2 plus 5. Yeah. 3 plus 4. 1 plus minus 10. Yeah. Because the minus, so 1 plus minus 10. 2 plus 9. 5 plus 3. 0 plus 2. Then I add them. 7, 7, minus 9, 11, 8, and 2. And look at the order of the resultant matrix. The order of the resultant matrix is still 2 rows and 3 columns. Yeah. So 2 cross 3, same as above. You do addition and subtraction, the order does not change. Remember, order does not change. Yeah. Order remain the same. Now let's say we want to do the subtraction of a matrix. So let's say I will use the same one. To do the subtraction of the matrix has to be the same order. So first we look at the same order. The order is same, yeah, order is same, so we can subtract the matrix. Now we can do the A minus. To do that one, we just put a negative there. So we put a negative there. That means subtraction. We also put a negative here because we are doing subtraction. So a negative, yeah. Now you follow exactly same method. You do 2 minus, you got 2 minus 5. Yeah. So that will become, if I just rub this bit, it's going to be the same one. So I can do 2 minus 5, 3 minus 4, 1 minus minus 10. You see the two minuses together. Usually the way I do is I write them together like 1 minus minus. And then what I do is I just do that. I just join them and make a plus. Yeah, because 2 minus makes a plus. 5 minus 3. 5 minus 3. 2 minus 9. 2 minus 9. 0 minus 2. So the 2 minus 5 is minus 3. 11. 2. Minus 1, minus 7, minus 2. And if you notice, the order of the resultant matrix is exactly the same.